Hello friends, welcome to my channel. So in this video now I am going to explain about the reagent chemistry, that is the most important reagent, sodium borohydrate. So in this sodium borohydrate, it is we are using for mainly selective reduction. So selective reductions will take place when you are using the sodium borohydrates. So sodium borohydrate, if you see this sodium borohydrate, we are using solvents like alcohols, because protonations will take place when you are using these alcohols. So see, in the sodium borohydrate, what are the groups it will going to reduce? So here SL chlorides, ketones, aldehydes and nitrogen groups containing. So these four groups will going to reduced when sodium borohydrate using. So mainly purpose of this sodium borohydrate is it will going to selective reduction to carbonyl compounds, right? So here I given some examples to you so that you can understand what is that exactly happening in the sodium borohydrate while using in a reaction. If you see here, we have a ester group, and here we have a aldehydes group. So only aldehydes carbonyl compounds will group reduced and remaining will keep like same. You don't touch, right? Here you can keep simply, you can write CH2OH, right? And you can keep as it is in this esters, because esters will not going to reduced. And here you can see where it will going to reduce. Here we have a ketones, right? Obviously you can reduce those things itself. Here you can write CH3 and H, okay. And next reaction you can see here. Here in this having you have a, it's very simple once you can understand this reagents chemistry. If you are using any reagent, so which group will react? So why it is using sodium borohydrate, why we are not using, why we are not, just to, you can ask me one questions to us, why we are not using lithium borohydrate? It is also reducing agents, right? Lithium aluminum hydrate, lithium aluminum hydrate, why you are not using those reagents instead of sodium borohydrate? So when you are using lithium aluminum hydrate instead of sodium borohydrate, so it is going to reduce carbonyl compounds as well as esters. So what is our aim, what is our requirement? So we need to reduce the only aldehydes group instead of esters group. So that is the reason only we are doing selective reduction purpose sodium borohydrate. So it will going to reduce to only aldehydes, not the key esters. So that's the reason only we are using sodium borohydrate instead of lithium aluminum hydrate. So you can see here we have a ketones here itself. So again you will write same the compound, but instead of ketone you can keep alcohols. Bulk, right? So this is for what, this reaction. And if you see here, what is that exactly happening in this reaction? We have a stereochemistry. In this reaction we have a stereochemistry, right? So hydrogen, where it will attack on this hydrogen, whether it is above the plane or below the plane, where it is going to attack, right? Where it is going to attack. If you see here, these are all things are above the plane. So obviously hydrogen will attack on above the plane, and OH will going, it is in below the plane right? So OH will give below the plane, hydrogen give above the plane, and remaining as is you can keep like that. Yes, yes, right? This is for what? Our product. So this is the reaction is called sodium borohydride. And once again one more reaction, sodium cyanoborohydrate. What is that sodium cyanoborohydrate? It is also no boron derivative. So why we are using this sodium cyanoborohydrate? Na3 NaBH3CN. Sodium cyanoborohydrate. Sodium cyanoborohydrate. So it is also selective reductions, but it is a bulky reduction, right? If you see in this reaction, aldehydes will more priority than ketone. Then ketones are more priority than esters. So in this esters also it is going to reduce when you are using sodium cyanoborohydrate. If you see one example so that you can understand what is that exactly this sodium cyanoborohydrate will do. Here I have a ketones and aldehydes. When I am using BH3CN, only one equivalence, methanol. So obviously what is the order? First order, aldehydes will react first and ketones then esters. So here aldehyde, here ketone. So which one will react first? Obviously aldehyde will react first. That is the reason only here we are going to take sodium cyanoborohydrate. If you are using sodium borohydrate, so both functional group will react. That's the reason we are not able to use sodium borohydrate instead of sodium cyanoborohydrate. So here again one more reaction. So this is for what? Sodium cyanohydroborate. This is the derivative of boron. So here we have a one ester group. While using sodium cyanoborohydrate methanol, so what will get? Obviously ketones will reduce instead of right. So you can keep OH, you can keep CO2, ET. This is for what? Our product. So that is the reason we are using sodium cyanoborohydrate instead of sodium hydrate. And if we see one more example, so that's it. This is for what? Examples today lecture. So if you see sodium borohydrate and sodium cyanoborohydrate, mainly what is that happening? If you are using aldehydes reducing agents, then we can get primary alcohols. If we have a using ketone reducing, then secondary alcohols will get. This is the main. You should understand that what is that reducing and everything. If you are using aldehydes to reduce, then we can get primary alcohols. If you are reducing to ketones, then we can get secondary alcohols. Okay, so this is for what? Sodium borohydrate and sodium cyanoborohydrate, and I will come next class in some other boron hydrates derivatives like lithium borohydrate and Luce's reagents. Everything I will come in a next class. Thanks for watching this video. Thank you. Jai Hind.